All right, for day 2 of section 3.3, we're still looking at polynomials and synthetic division. Okay, but let's make it a little more challenging. Okay, here is a key though. It's written in red right here. Make sure that you realize that roots for irrational numbers, okay, irrational numbers like square root of 2, and imaginary numbers like 2i, okay, they come in conjugate pairs. All right, so they always come in pairs, which means when I tell you in problem 1, solve for x, notice we're starting with x to the 6th, which means we should have 6 solutions, right? Up to 6 solutions. Now, if we're allowing imaginary numbers, then we're going to have 6 solutions. Okay, so we definitely have to think about if they're asking us for real or imaginary. Now notice, when I tell you, based on what we just said in that red statement up there, when I tell you one root is -3, I'm really giving you 2 roots, and that's what you've got to realize. They come in conjugate pairs, because that's an irrational number. So root 3 is a root, means -√3 is also a root. Okay, so here we go. Let's start. If it's a root, that's what goes in the batter's box, right? Okay. So coefficients going across, you could turn this off and try this yourself. Challenge yourself. See what you can do. All right. Coefficient should be 1, 0. Don't put them too close together is another tip. -5, 0, 2, 0, and 24. I'll draw my line, and we'll start. Drop this. 1 times √3 is √3. Add straight down, √3. √3 times √3, 3. Add straight down to get -2. -2 times √3 is -2√3. Add straight down. Okay, √3 times -2√3. Well, √3 times √3 is 3, times -2 is -6. And if we add straight down, sorry, this is supposed to say -2, right? Because that's the x squared. -2 and -6 would be -8. -8 times √3 is -8√3. Add straight down to get -8√3. Remember, they told you it's a root, so what are you expecting for the remainder? Right, it better be 0 or you know you messed something up. √3 times √3 is 3 times -8 is -24. Enclose that final answer of 0. That is my remainder. That's beautiful. Perfect. Now, remember, my whole goal is to get down to a quadratic or a quadratic type, something I know how to factor. So guys, I just did all that beautiful work. I've now depressed this equation from x to the 6th to x to the 5th. Well, I don't want to start over with another root and go back to x to the 6th, because the only thing I can depress it to is x to the 5th, which means, here's the key. Once you have a root, you now use these as your coefficients. That's what you're going to divide into. And if it's truly a root, again, your remainder better be 0. This is another reason you box that remainder at the end, okay, because it's not part of this. So I will get us some room, take these away for a moment, and I'll just start with a new batter's box. We said if √3 is a root, then -√3 is also a root. So here's where your new batter's box goes. Your line only goes over to here now. And try it again. There's 1 times -√3 is -√3. Add straight down to get 0. 0 to get -2. -2 times -√3 is +2√3. Add straight down to get 0. 0 times √3 is 0. -8. -8 times -√3 is +8√3. Box it again. Add straight down to get 0. Okay, perfect. So this has now turned into, think about your coefficients. You depressed it once from x to the 6th to x to the 5th, and now you're looking at x to the 4th. So let's write out what this is. This is really x to the 4th. There's 0x cubes. So minus 2x squareds, there's 0 x's, and minus 8. Well, guess what, guys? If I'm trying to solve for x, remember that was where the directions, solve up top. You're setting this equal to 0. You can't forget about the answers you already found, right? You better have how many answers? 6. Well, this is quadratic type to me, right? So x squared should go in the front of each. Once you do that, the numbers to give you the 1, the negative 2, and the 8 would be, let's see, negative 4 and plus 2. So this factor is difference of perfect squares, x plus 2, x minus 2, times x squared plus 2. We know the difference of perfect squares factors that way. The sums of perfect squares, like we've talked about before, only factors with a imaginary number. Okay? Remember, again, as long as it's okay that you're just thinking about it, and we'll talk about that in a second, I'm fine with you going ahead and saying, yep, since we're talking about imaginary numbers, I know that the x squared plus 2 factors into x Let's talk about it step by step. Square root of x squared is x. The square root of root 2, or sorry, the square root of 2 is the square root of 2. One's plus, you know it has to have an I, and one's minus, and it has to have an I. The I, multiply those back out. Prove it to yourself. Okay, the I is what will change that sign and get you the x squared plus 2. So it's almost like difference of perfect squares, but it has to have an I in it. And then please do not forget your other two factors, which are from the original that we gave you. One of them is x plus root 3, and one of them is x minus root 3. Okay, so again, I'm going to just keep making that note. This is okay to think about it this way. But one more time, I will say technically, there are no roots or i's in factors. Okay, so luckily this was a solved problem. The reason, again, I like seeing that is because it's easy to see my answers. I can see the 6 answers. I don't mess up extracting square roots and forgetting the plus or minus. Okay, so from above then, guys, you can just tell me that x equals plus or minus 2, plus or minus I root 2. Don't forget i's go in front of roots when we're handwriting them. And plus or minus root 3. There you go. There's your 6 answers that you should expect since it was x to the 6th. Okay, let's do one more solve. Again, let's just do one that's a little more complex. Again, we're solving. It's x to the 4th. Whole goal is to get it down to quadratic, right? Something that we can factor, quadratic or quadratic type. Obviously, that's not quadratic type yet. Again, me giving you 1 root is really me giving you 2 roots. You have to know that automatically. There is an imaginary number. It comes in conjugate pairs. So if 2 plus I is a root, then 2 minus I is also a root. Okay, so here we go. 2 plus I up in the batter's box. 1, leave yourself a lot of room. Negative 4, 2, 12, and negative 15. Okay, draw a line, drop the 1. 1 times that quantity, yes, you have to distribute it, but it would be 2 plus I. Adding straight down, make sure you're combining like terms. So negative 4 plus 2 is negative 2, and there's no other I term, so just plus I. Ooh, 2 plus I times negative 2 plus I. Yeah, you've got to put parentheses around those, and you got to think about distributing. Okay. So 2 times negative 2, I'm just going to do a little work up here. I'm just going to give myself a little bit of room. Is negative 4 The 2i and the negative 2i on the outside are going to cancel, and the I times the I is going to be plus I squared. All right, so what am I really getting? Really looking at negative 4 minus 1. Okay, so I just did a little bit of work in there. I'm really looking at what? Negative 5? Okay, so 2 minus 5 is negative 3. And even if you want to put the minus 5 in there, that's fine. Up to you guys. 12. Okay, I'm just trying to show it to you. Sorry, not 12, but if you're multiplying negative 3 times the 2 plus I, make sure you distribute it. So you're going to have negative 6 minus 3i. Add straight down one more time. 12 minus 6, because those are the like terms, is going to be 6 minus 3i. Again, ask yourself, what are you expecting this remainder to be? That's the key. If it's not 0, you know you did something wrong. You might as well go back and fix it. Okay, you've got a binomial times a binomial, 2 plus I times 6 minus 3i. Go ahead and work that out for yourself. 2 times 6 is 12. Okay, 2 times negative 3i, negative 6i, plus 6i, right? Those cancel. And then I times negative 3i, sorry, will be negative 3i squared. So again, I'm just doing a little bit of work. I'm not going to mess up because I'm not writing something down. I don't want to do too much in my head. Again, that's going to turn into 12 plus 3. So yeah, I'm looking at 15. So negative 15 plus 15, there we go. That's the 0 I desired. Again, you have worked so nicely to make this from x to the 4th to x cubed that I don't want to take the other root and start over through the x to the 4th coefficients, because I'll just keep spinning my wheels. I'll keep getting to x cubed. You want to depress that equation one more time, if you will, until you're down to a quadratic that you will know how to factor. Okay, so if 2 plus I is a root, that means 2 minus I is a root. All right, it only goes through these. Why don't you go ahead and practice it for yourself? Drop the 1. You'd have 2 minus I. Add straight down, 0, 0, negative 3. Distribute, negative 6 plus 3i. And awesome. It does give me the 0 that I expected. Okay. So now you are left with, think about it again. This was x to the 4th. It got depressed to x cubed, depressed one more time to x squared. So think about what this is telling you. It's really saying x squared plus 0x minus 3 equals 0. Since we are solving for x, you know it's got to be equal to 0. Okay. So why don't we just start with this one? This is one of your factors, x squared minus 3, that we just got. And then up here, if x equals, this is just a little bit different, but if x equals 2 plus I, I'm just doing that from here. Well, then that means the factor, guys, it means get it equal to 0. So if you just move everything to one side, isn't it x minus 2 minus I equals 0? Okay, so you'll understand where this factor is coming from then. X minus 2 minus I. Again, this is just us thinking about it because we wouldn't have i's. And the other one is 2 minus I. So if you move those both to the same side, you'd have x minus 2 plus I. Okay. I can make x squared minus 3. I can force anything to be difference of perfect squares. Again, square root of x is x. Square root of x squared is x. Square root of 3 is root 3. One's plus, one's minus. And then I'll just recopy the other two factors. Remember, these are only for us to think about. We would never actually give that as an answer for factors. Okay, so once again, just to make sure we're on the same page, okay to think about it this way. And I think it actually makes you a little more successful to not leave out some of your answers. Now remember, I'm not going to dox that because we're not actually factoring. We're actually asking you to solve. Solving or finding roots, finding solutions, finding zeros. All of those have to mean the same thing to you. So you do need to practice with directions also. Okay, from above, you would see then that x equals plus or minus root 3 and 2 plus I and 2 minus I. If you just set each factor equal to 0 and then move it straight across and solve. Okay, there we go. So it does not get any harder than that. That's it. You've kind of gone through all of those. So do a good job of practicing those. Good luck.